Right, guys. Right, please just close your laptops for a moment. Close your laptops, Maria, put it away, or I will run it into 1,000 pieces. Eat it, and never see it again. Right, I'm going to go through one example. It's one of the simpler ones, but the problem that I'm seeing with actually most people is that there's becoming confusion between charges and oxidation numbers. Okay, people are starting to write numbers just in strange places. Suddenly, one number goes wrong in these kind of questions, everything goes wrong. So, first of all, first step, I need to identify ionic compounds or acids. In this case, actually, it's fairly straightforward. Do I have any ionic compounds or acids, Amaya?
Yeah.
Yes, which one is my acid? It is this. This is my hydrosulfuric acid. That's the only thing in this equation I separate. So when I write it again, actually the oxygen is going to stay exactly the same. I then am going to have two H pluses. I'm going to have one sulfide, two negative charges. Nothing else changes. Okay, now in that first thing I've written there, is that a charge, or they charges or oxidation numbers? They are charges, I know that. First of all, because I've taken it, or I've deduced them, by separating something that is a nice neutral compound. Therefore, when I separate it, as we know with acids, it produces some positive things, some negative things. Okay, they're charges. I've written the number before the symbol, and I've written them to the top and to the right of the species, of the thing. Okay, so they are definitely charges. Oxidation numbers. Where do I write oxidation numbers? Yeah, I write them on top, directly above. I recommend even doing it a little bit higher. It might look a bit strange. So, for example, with oxygen in its elemental state, what's the oxidation number? 0. I'm going to put it just nice and high out of the way so I don't get confused later when I have my charges. What about H plus? So plus 1. I'm going to put it nice and high. People are starting to write things kind of here. It starts to get chaotic. People start to get confused. So write it nice and high out of the way. Sulfide. What's the oxidation number for that? -2. Get that out there. Sulfur, its elemental state is 0. Good. Hydrogen always. Because it is 0. There, it's not, because that we say is in its elemental state because it's on its own. There's no charges or anything else associated with it. Here, the sulfide on the left has 2 negative charges. I don't just find things out in the woods when I'm walking around with lots of negative charges. So it's not the elemental state. Okay? Right, where are my changes happening then? What's being oxidized or reduced? What's changing in S? Sulfur is changing from, I'm going to put a nice square around it, from -2, and we're talking about oxidation numbers here, and not charges, even though they happen to be the same in this case, and it's going to 0. If my oxidation number is going up, it's getting more positive, is that losing or gaining electrons? If it's becoming more positive, it must be losing those negative electrons. Oxidation is loss, so that is oxidation. The other thing that's happening is what? What else is changing, Carlotta? Yeah, the oxygen. The hydrogen is actually staying the same. The oxygen is not. Now, actually, I can know if I've identified the first one as oxidation, what must the second one be? It must be the opposite. Why do I not separate water? Because it's covalent.
But when you take the reduction thing,
Yes.
you take hydrogen.
So when I write my next half equations, the mini equations, the reason I've done this first step is because I must take the whole thing where my element, in this case oxygen, is. Okay, I must take that whole thing. That's the step people start kind of making up their own rules. They start then separating this, and I've got things all over the place, and everyone gets lost. Okay? So to write, I'll go through this second part very, very quickly. We've identified those two. Let's write my oxidation equation. I've got sulfur, 2 negative charges. My reduction, I've got oxygen molecule and water. Right, to balance the first one, are the sulfurs balanced?
Yeah.
How many sulfurs do I have on each side, Esteban? One and? One, fine, balanced. What's not balanced, Esteban? Charges, where am I going to add something? What am I going to add? What can I use to balance charges? 2 electrons. That is done. Second one, slightly more complicated because I've got more than one element. Oxygen, let's start balancing the oxygens first. What can I use to balance oxygens? Water, I use water. Where do I put another water then? I've got 2 oxygens here, 1 there. I need to add another water to the right. Now I could put plus H2O, or more simply, I could just put a 2 in front. Why don't I? Because if I do that, if I put an H2O here, how many oxygens on the left? I now have 3 on the left, 1 on the right. I need to, this part, I'm trying to balance my oxygens. So by doing that, I balance my oxygens. Now the hydrogens are not balanced. However, when we've got these acidic conditions, how do we balance hydrogens? I can add H pluses because they're floating around in my reaction mixture. How many H pluses do I need on the left? I need 4. Finally, how do I balance the charge? I've now got a total of 4 positive charges on the left, none on the right. So where do I need to add electrons and how many? I need to, on the left, how many? I need to add 4, bit of a squeeze in there, 4 electrons there. The next step, I've got 30 seconds, 30 seconds, I need to be able to cancel out my electrons. Why have I put them on that side? Because I need to make sure after I add some electrons somewhere that the charge on both sides is equal. Before that, I had neutral stuff on my right side. I had 4 positive charges on the left side. So by adding 4 electrons to the left, they cancel out the 4 pluses, and there's neutral on both sides. Next, to make sure when I add these 2 back together, I need to balance my electrons so I can cancel them out. I need to multiply this top equation by 2, which means, and I will again be a little bit naughty and skip a step, when I add those back together, after multiplying this top one by 2, I have 2, S2 minus. That is now adding everything I had before together. What can I cancel out in that equation now? The electrons. That's the whole point of this process, is to be able to make sure that the number of electrons moving around is the same. That's the kind of the most important step. And then finally, what I need to do is make sure that all of my stuff now becomes the original ingredients once again. So, sulfide and the H pluses came from hydrosulfuric acid, if you remember, this from the stuff here. Therefore, I need to combine them to make that stuff again. In this case, I've got 2 sulfurs. I'm going to need 2 of those hydrosulfuric acids. Have all the hydrogens gone? I needed to use 4 hydrogens. I've now got rid of 4 hydrogens as well. Perfect. That's disappeared. That's disappeared. Oxygen was in my original equation, so I can keep that as it is. Sulfur was in my original equation, and water was in my original equation. That's now gone, that's now gone. There is my balanced equation. So the one bit we need to be careful of, that people get a little bit lazy, is the difference between oxidation and charges, because we're literally one wrong number and the house of cards comes falling down.